So thank you very much for coming to my talk. My name is Ondřej Mirtes, and I've been developing in PHP since 2005 on projects both big and small. But the reason why I'm talking to you today is because I like pointing out mistakes in other people's code so much that I created a static analyzer that focuses on finding bugs in your code without running the code. And I've been developing PHPStan since 2016. And recently, I started working on it full-time. So this is now my full-time job. So who already uses PHPStan? Well, almost everyone. And who uses generics, which we are going to be talking about today? All right, so you will learn a lot. That's awesome. So we can probably skip the basics of running PHPStan. So this is how we can install it. This is how we can run it. It's going to tell you a lot of things that is wrong about your code. So for example, PHP itself is happy if you mention classes that don't exist in any of these cases. So PHP will just stay silent if you ask about something that does not exist. It will even happily create an unknown class name for you, even if this doesn't exist. But PHPStan will tell you all about these errors. But I want to introduce generics today. And it's a really complex topic because generics is basically a programming language inside a programming language. So it's a really complex topic, but I hope to introduce it pretty easily for you. And I'm going to be using a lot of examples so you can kind of get a good idea how they work and how you can write your own generic code. So the simplest explanation I came up with is that generics allow you to create an infinite number of signatures for your function. So imagine a function that returns the same thing, same type that it receives. So in case of integer, it returns an integer. In case of string, it returns a string. And in case of float, it returns a float. So without generics, without any special advanced concept, we would have to type it probably like this. We accept anything and we return anything. But of course, that's going to produce an unnecessarily wide type. So if you don't use generics, you can probably find yourself having these errors reported. So if your function returns an unnecessarily wide type, you're probably going to get errors like call to an undefined method object do foo, because you cannot just safely call any method on the object type. You need to have a specific class name, specific object type to be able to call methods on it safely. If you just return mixed from your function, you will also get errors like these. Cannot access property on mixed. But on the other hand, if you use generics, your code will be more safe. And in some cases, you will get more errors reported for a good reason. So for example, if PHPStan knows that your function is going to return a specific class, specific object of a class, and you then will call an unknown method on that class, PHPStan is happily going to report it, and you will be able to fix your error this way. So on one hand, generics is going to make sure that you have less false positives, but on the other hand, it's going to report more correct errors for you. And it's all about making types during static analysis more specific. And PHP itself does not support generics out of the box because it's a really complex thing. There used to be an RFC back in 2016 about this, and it didn't go anywhere. And there's GitHub repository with a lot of useful information that you can read on why doing generics in PHP itself is a really complicated topic. So generics isn't in PHP, and if it were, it would look something like this, using native syntax, but this isn't possible. And the best we can do today is to use PHP docs. So this is how it can look using PHP docs. You need to introduce something called type variables. So you have add template, and you can put just about anything as a template type variable name. So the convention is usually just a single uppercase letter, but it can be anything as long as you're not using a valid class name. So that really wouldn't work, but you can use any identifier that's not occupied by an existing class. And with this kind of signature, the function behaves exactly as we want to. So it accepts a type and returns the exactly same type. You can also limit what the type variable can be. So in this case, we are only accepting exceptions. So we use a type variable bound, and we say template t of exception, and this function will only work with exceptions. You can also reference and require a string with a class name, which is useful in a lot of cases. So in this case, we type hint class string angle brackets t, and then we can return an object of that class. So if your function call or method call looks something like this, you want to find an entity by its class, you can type in a class string, and then you can return the object of that name. So in general, how generics work for functions and methods is that for each method call of a generic function, PHPStan looks at the parameters. It tries to infer what the type variables are present in that parameter. And then the knowledge of what t is, it's going to apply it for the return type. And you can combine it however you want. So in this case, we are finding all the entities of a certain class name. So we are accepting a class string, and we are returning an array of these. So it's going to return an array of objects of the type of the class name that we passed in. So I have a little quiz for you. Please look at this signature. It has multiple type variables, and it also has some callable signatures. And I want you to guess what function this is. It's a function from PHP. PHP itself. It's a built-in function. So if you know the answer, just shout at me. Array map, yes. So it can get pretty complicated, right? So we need, for the thing that we want to achieve here, we need 3 type variables, k, v, and v2. And the first parameter is callable that has the type hints some kind of type here and returns a different type. And then we accept an array of types k and v, and we return a different array that's going to have v2 as values here. So this is how it works. And PHPStan, when you are calling this function, PHPStan looks at what kind of callback, what kind of callable you passed in, and what kind of array you passed in, and then it's going to generate this return signature. And it will also tell you if these two do not match, because there are some special rules around callables. So if you are just repeating the same type here, it's going to check that you are accepting actually the correct array value type here in this callable signature. So it can also, besides returning the correctly inferred array here, it can also find bugs in your code. So for example, if you have an array of integer and nulls, for example, but here you are just type hinting an int integer, PHPStan is going to tell you that you are not handling nulls here. So it can also find a different family of bugs in this case. All right, so up until now, we use generics, we used type variables only above functions. But a whole another area, the area that the rest of the talk is going to be about, are type variables above classes. So we can also make not only our functions and methods generic, we can also make our classes generic. So once a class has one or more template type variables, we call that class generic. And once we use type variable above a class, we can then reference this identifier in our methods and properties. So once we have t above a class, we can use that same identifier above methods in our parameters and return types. And once a class is generic, we can type hint what those type variables are when we use that class. So right here, we made our collection generic, which means that we can type in that it's a collection of docs. And when we try to use this collection and we try to add something that doesn't belong in that collection, static analysis, PHPStan are going to tell us about it. And here the order matters. So the first template is going to belong as in the first position in the first place, and if we have multiple templates, the next ones are going to belong in the next positions in that time hint. All right, so when we are type hinting our collection in parameters and return types, it's going to look like this, but we can also use classes a different way, right? We can, if that class isn't final, or if we are talking about an interface, we can extend and implement these things. So it's also important to specify what those type variables are when we are extending these generic classes and interfaces. So we have a new PHP doc tag for that. So it actually matches the keyword. So we have at extends, and we need to specify what the type variables are, and it matches the extends keyword from PHP. And when we are extending a generic class, we can decide if we just want to specify what the type variable is, or we can keep the kind of genericness of that class. So both of these are valid. We can either say that we are just writing a doc collection, and we are sure that the t variable of collection is always going to be a doc. We just want to write some, or we just want to write some new methods for the parent class, or we just want to change the behavior or something. We can just say that it's a collection of docs like this, or we can preserve the type variables, and we can just create a new, still generic, better collection if we just repeat the at template and we pass the t to in the extends tag like that. We can do the same thing for interfaces. So at implements matches the implements keyword, and even traits. Who uses traits? They can be generic too. So you can make trait generic, and you can just say what the template type is using at use keyword. All right, so these are the basics. And the next thing that people usually have some problems with is that they try to use generic classes and PHPStan yells at them for some reason. And because they probably haven't read documentation, or they haven't heard talking me about this, they don't know what to do with it. So if you have some code like this, we accept a reflection class in a parameter, and PHPStan yells at us. Method hello world, say hello, has parameter with generic class reflection class, but does not specify its types. What would you do about this error? To ignore it is not the right answer. What do you think that PHPStan wants you to do here? Yes, it wants you to add a PHP doc that specifies what T is for this class. Because a reflection class is a built-in PHP class, but PHPStan uses stub files to make some built-in classes generic because it's really useful in some cases. So this is actually how the declaration of reflection class looks like in PHPStan, how PHPStan sees it. So reflection class is generic, and this is one of the possible solutions that will make PHPStan happy about your code. So you can just say that it's a reflection class of whatever. It accepts any object. So this is all right. You need to tell PHPStan what's going on. So object is one possible solution. So if you just don't care about generics in this situation and you want to put something there, you can use the same thing that the template has as a bound. So you can just use an object or mix it. If the bound is missing, you can just use mixed. So one possible solution is an object, or you can just say that you accept reflections of only a certain class. So you can just put foo there. Or maybe the most complex situation is that you can also make the function also generic. So you can just say that this function is generic, template T of object, and you can just pass the T in here. And the good news about this is that you can just work with this T. So for example, if your function returns a new instance of the reflected class, this is going to make it safe and okay for PHPStan. So you just use the T that you used here, and when you pass in a specific reflection class, when you are calling this method, PHPStan is going to extract what T is and is going to use it as a return type. And I see that I have a typo here. There shouldn't be void, there should be object because we are returning something. So sorry about that. So another one, very similar situation. We have a class that implements a generic interface, and PHPStan complains about the same thing, does not specify its types, T key and T value. So we need to use at implements, and we also have many options what we can put there because only you know what your code does. So you should make sure that this information is truthful and useful. So this tells PHPStan what happens when you put an object of class foo into a for each, what it's going to iterate over. So in this case, the iterated keys are going to be integers, and iterated values are going to be objects of class butter. And you can still pass out the genericness. So this example makes class foo generic, and we introduce two template variables, and we just pass them over to the implemented interface. And we can also decide, it's really flexible, so we can also decide that we want our class to be only generic with a single template type variable, and we decide that the keys will always be integers, and we only pass the type variable as the value for the interface. So that's that. And PHPStan makes a lot of PHP classes generic, so you can just inspect how the stubs look like. You can just follow to PHPStan's GitHub and look at the repository and see what kind of stubs are there. in this directory. And this is how the stubs usually look like. So we have this is a stub for array iterator. So we have two template types, and we implement several interfaces. So we say two of these interfaces are generic. C-coupled iterator is generic, and array access is generic. So we implement them, and we tell PHPStan how the template types are passed there. And this is just a stub file. So the method bodies are empty because PHPStan in this case is only interested in the PHP docs and uses them instead of the original PHP docs of these classes. So stub files are useful for PHPStan because it can kind of override what it thinks about PHP, about built-in PHP classes. And you can also use stub files yourself if you are not so happy about, for example, third-party dependencies that have wrong PHP docs, or maybe you are using some third-party class that you wish to be generic, but the creator of that dependency doesn't know anything about generics. So you can use stub files also to override or improve wrong third-party PHP docs. And you can learn about stub files in the documentation on PHPStan's website. So I also want to tell you about more complex scenarios, if this wasn't enough for you as a last session of today. So this is a pretty common problem. We have some kind of interface that's supposed to consume messages, and we can only put just a very, very general interface called message. But we have concrete messages, we have specific message. And we implement this interface in an index document consumer. And here we cannot type hint a more specific thing because that wouldn't be valid PHP. We can only type hint this type or wider. But we know that only code that's ever going to call this consumer is going to pass the correct message there. Has anyone ever encountered this kind of code? Yes. So the problem is that PHPStan only sees this type hint. It only sees the message. But we as developers, we know how our system works, and we know that this is actually index document message. So PHPStan is going to complain that we are accessing something that does not exist because it only sees this type hint, but it's actually index document message. So this is where generics can help us a lot, and we can introduce these PHP docs that I marked green, and we can make the consumer generic. We can put the template T in the parameter type. And when we are implementing index document consumer class, we can say what the T is in the interface that we are implementing. And now PHPStan knows that this is index document message. And it's going to work. It's not going to complain, and it's actually really type safe. So does anyone have any questions about this example? I'm going to give you a few seconds to process this. All right, Dave, please. Sorry? Yeah, sure. Of course, it's just an example. All right, so this is how you can improve your code if the language rules are kind of limiting you, because you can't put this, you can't put index document message here because you can't narrow parameter types. You can make them wider, You can, in PHP, it's valid to put, for example, message or null here, or maybe mixed, but you can't narrow it down. But if you use generics this way, you can do it, and it's still sound. It still works correctly. All right, another maybe even more difficult example. So you can use generics to couple relevant classes together, and we can be talking about command and command handler or something like that. I'm just using some general names here. So let's say that we have some kind of original class, we have derivative class, and we have my original and my derivative that implement these interfaces. And let's say that we have a function that accepts an original and returns the right derivative for that original. So we expect that when we pass my original into this function, we should get my derivative, right? And PHPStan doesn't know about this behavior. So when we try to test this returned type, it's going to tell us that it's a derivative even for my original. But again, we know because we wrote that code that it's going to return my derivative, and we want to rely on this, and we want to maybe call some specific method that's only on my derivative when this code continues below. By the way, this is a useful function. If you ever want to know about what PHPStan thinks about your code, if you want to know what it inferred about your code, you can always use dump type with any expression here, and it's going to tell you what precisely it knows about this type. And you are supposed to rerun the analysis of this code. So it doesn't do anything. It doesn't exist at runtime. You're supposed to reanalyze your code with PHPStan, not run it. This function doesn't do anything at runtime, but at static analysis time, it tells PHPStan to print in the output what kind of type it thinks it is. So you can use it to debug static analysis. So how to solve this example? Somehow we need to go from my original to my derivative. We need to instruct PHPStan what it should think here. So we are going to make original generic. We can name the type variable t derivative. And when we are implementing original, we are going to say that my original is an original interface, and the t derivative is my derivative. And when we have set up our classes this way, we can then write this signature for our function. So we create template t with derivative bound. We accept an original, and then we instruct PHPStan to extract the t from the original and just return t. So this is how we can extract my derivative from my original like this. So with this kind of setup and with this signature, we can tell PHPStan that it accepts, when the function accepts my original, it's supposed to return my derivative, because we connected our classes this way. So you can see why I told you that it's like a programming language inside the programming language, right? All right, so conditional types. Sometimes you don't need the power of generics, because generics always want you to go from a specific type and do something with the same type. So maybe it's sometimes too limiting. But sometimes you only need a simple if-else condition. So if I tried to solve this with generics with type variables, I really couldn't. But sometimes people try, and PHPStan tells them that they are doing something wrong. But what they actually needed was a simple conditional return type. So this is how you can do it if this function, when true is passed in, it returns full, and when false is passed in, it returns full or null, because the need parameter probably throws an exception if the thing is missing and you passed in true. All right. So to continue and to tell you about even more complex stuff, I need you to understand these terms. So covariance and contravariance are terms describing relationships between types. So who has ever heard of these terms? All right, few people. So we have less specific type called animal. We have more specific type called dog. And when we are going from less specific type to more specific type is covariance. And when we are going from more specific type to a less specific type, it's contravariance. And if we are talking about same type, it's invariance. So the relationship between animal and animal is always invariant. But when we are talking about more specific, it's covariance, and otherwise it's contravariance. So another setup. We have an interface animal, and then dog implements that interface, and cat implements an interface. And we have a generic collection that's going to be about what kind of contents, what kind of values are in this collection. So you might be surprised that when we have a function that accepts a collection of animals, and then we have a collection of dogs, the function that accepts collection of animals is not going to accept collection of dogs. So with this kind of setup, you will get this error message. Parameter of function accepts collection animal, but collection of dogs is given. So this is weird, right? This looks like a bug because dog is also an animal, right? But in generics, you can't really do this because the function that accepts a collection of animals might actually put there a cat. So the code that adds a cat to add collection of animals is okay, it's all right, this is valid. But the code that tries to put dogs there isn't valid. So because sometimes we want to write a code like this to add something more specific to a more general collection, we have to reject types in these cases, even if it looks weird at first. And when this happens, I prefer to tell users some contextual information, contextual help. So if this happens, PHPStan is also going to print a useful tip with a link to an article that explains why is this rejected, because it was the most common question asked on the support in GitHub discussions in the support forum. So in this case, it's not allowed, and what we need to do is to use something else here, because this is invariant template without any special modifier. It's invariant, so collection of animals is only going to accept collection of animals. And if we want to allow collection of dogs into collection of animals, we need to use @template dash covariant, which is going to tell PHPStan that this is okay. But on the other hand, template covariant is not going to allow you to use t in a parameter, because once we allow this, we actually cannot allow to add cats in this function, right? So once you use covariant and you have your collection accepted in this case, you can no longer use t in a parameter, which is also limiting, right? So we just moved our problem elsewhere, and we have a different problem. So in this case, PHPStan is going to complain template type is declared as covariant, but occurs in contravariant position because parameters are contravariant. They can only be the same or wider. They cannot be more specific. So this is why this error message is pointing this out. So this is a useful table of these limitations. So in case of invariant template, we cannot pass collection of dogs into collection of animals, but we can have t in a parameter position, right? But in case of template covariant, we can pass collection of dogs into collection of animals, but we cannot have t in a parameter position. All right, so for a long time, the story stopped there. You could have one, but you couldn't have the other. But recently, a contributor contributed something to PHPStan that was inspired by other languages like Kotlin. And because he worked with Kotlin and he explained it to me how it can be solved, we actually solved it. And the solution is called call site variance. Why is it called call site variance? Is because this is a declaration site variance. When we are declaring our collection, we are saying what the type variable is going to be. But in this case, we are saying it on the call site. So as a setup, we need add template as invariant because we want to use t in method parameter. So we need invariant template. But then what we can do is to do this. So if we want to accept collection of dog into collection of animals, even when t is invariant, we can just declare the covariance here when we are asking for that collection. So this is a pretty new feature in PHPStan. I think it was released in the last month. So you can kind of do this to lift these limitations but to still have your code type safe. So there's going to be another catch, right? This is not everything. So this to declare the variance at the call site to make t as covariant, PHPStan is not going to allow us to call methods where t is in a parameter position. So, but this to use covariant animal is okay if you just want to get values out of this collection. Then it's going to be totally fine. So, yeah, this is how you can solve these kind of problems if the initial generic declaration of your class is limiting you. And you see why this is not allowed, right? Because if we allow collection of dogs there, which is allowed, we really cannot put cats into this collection safely because you would have cats and dogs on the same heap. So yeah, that's it. And if there's a covariant declaration, you can also have contravariant declaration, and it has different kind of limitations. So if you do contravariant, this collection is going to accept collection of dogs, but also a collection of animals, and basically about any collection. So you're going to lift the limitation from the other side. You cannot put a more specific collection there, but you can put a less specific collection there. And you can also with contravariant declaration, you can put dogs there safely because collection of dogs is going to accept it, collection of animals is going to accept it, and collection of mixed is also going to accept it. And the thing that it's going to do is that in a return type position, you cannot rely on anything. So you can call the method that has t in a return position, but PHPStan is just going to tell you that it's mixed because a collection of mixed is accepted here. All right, and one last thing is something called a star projection, which is also from Kotlin and which I didn't hear about before I talked to this contributor that helped me get this into PHPStan. And this is kind of a limitation from both sides. So you can accept just about any collection in there. There's no limitation on the type, but you can't call methods. You can't call methods that have this type variable in a parameter position. And when you are going to ask about return type of t, it's going to return mixed. So you can see how this is both covariant and contravariant call side variance applied at the same type. And this star projection is useful if you are interested in asking about something that is not relevant to the contents of the collection. So for example, if you just want to ask about the number of values in that collection, you can use the star projection, and it's totally okay because you are not interested in the contents, in the actual values. You are just interested in other properties of the collection. All right, and you can read all about this at these places. So if you go to phpstan.org, you click on documentation, you click on writing PHP code in the left sidebar. You can then read about PHP doc basics and PHP doc types, which is going to tell you everything that you can express in your PHP docs. And if you want to read everything about generics, maybe at a bit slower pace than I just did in my talk, you can read all of these articles about generics on the PHPStan website. So you go to blog, you go to guides, and then you can read about generics in PHP using PHP docs. And because not everyone understood it, I wrote another article, generics by examples. And what I did today was more about examples instead of all the theory that you can do with generics. And you can also read the last two articles, which are about why, by default, collection of dogs isn't accepted by collection of animals. All right. And if you have any questions, you can, of course, ask them right now. And if you have any questions later, I encourage you to ask on PHPStan GitHub in discussions, and either me or maybe some other people will answer you as soon as possible and give you a solution to your problems regarding static analysis. Okay, thank you very much. Does anyone have any questions now? Yes. It's already released. Okay, cool. All right, anyone else? Okay. PHP Storm already supports generics, but there's probably no support for the call side variants yet. But basically any other feature of generics it already supports, including auto-completion and understanding what's going on in those annotations and so on. But I need to reach out to them about the call side variants. All right, anyone else? Okay. Well, it's difficult to like make the right abstraction for this so that other people can use it. Right now, that we have different implementations in all of these tools. For example, if I even abstracted this, the PHP Storm team couldn't use it because it's written in Java. So I don't know how much useful it is. right now, the PHPStan documentation is like the canonical place that they should read and understand how it should work. So that's the best that I can offer right now. All right, any other question? Okay, so thank you very much. Maybe catch me later. And if not today, then definitely in GitHub discussions. Thank you.